Moving on to the second equation of motion. What we are going to do is, we will find out the area under this VT graph, which is going to give us the change in position, which is also the displacement. So I have broken down the graph into two parts for you for sake of better understanding. So you can clearly see that the area of this rectangle is UT, correct? And the area of this triangle being half times base times height being V minus U. So which means the total area, which is going to give us the change in position. So change in position is the sum of both these areas, UT and, so basically it becomes UT plus half V minus U times T. Right? Now what is change in position? It's final position minus initial position. Yeah? Equals UT is still there, okay, plus half. But if you look at this, I can write V minus U here as AT, right? So if we substitute there, it becomes half AT square, okay, I written off already there. So instead of V minus U, I am going to write AT, so it becomes AT times T, correct? Okay, so let me first write this side, so it becomes UT plus half AT square. Now what we are going to do is, for simplicity, we are going to make the initial position to be 0. That's an assumption which we are making. Please understand that it is just an assumption. It need not be 0. For simplicity, we are making initial position to be 0 here. So this becomes 0, right? So you've got only final position left with, and that we are going to represent with S. So this becomes your second equation of motion. So let me quickly explain you the terms here. S represents the final position of the object at any instant in time. U being the initial velocity at time t is equal to 0, t being at an instant in time, acceleration, and so on. So this is the second equation of motion. To find the third equation of motion, we will have to use the first two equations of motion to arrive at the third one. So the second equation of motion being S is equal to UT plus half AT square. So what I am going to do is, I am actually going to eliminate T from this equation. So to do that, I am going to find T from the first equation of motion to be V minus U by A. I am going to substitute it here instead of T. So it's T squared here, so it becomes V minus U by A whole square. So I'm just removing the brackets, so UT minus U squared by A, right? I've expanded this, so you get 1A out of the equation. Now if I take LCM between these two terms, it becomes 2A. So which means automatically this becomes 2UV, this becomes 2U squared, and these are V squared plus U squared minus 2UV. So if you quickly check, 2UV and minus 2UV disappears. So these two terms becomes minus U squared, right? So on the right hand side, I have S. So you have V squared minus U squared by 2A on the other side. So if I rewrite this, I get V squared equals U squared plus 2AS. That's your third equation of motion. Thank you. Coming to the fourth equation. Now, in order to arrive at the fourth equation, we are again going to use the first two equations of motion. But this time we are going to eliminate A instead of time. So, as I show it here, A is equal to V by U, V minus U by T. So, if I replace A in the first equation, you get S is equal to UT plus half V minus U by T times T squared. So, 1T disappears. So, I am multiplying T inside. So, you get UT plus half UT minus UT. Now, if I expand the bracket, that's what you get. So, you get UT minus half UT, that becomes half UT. Right? So, if I write the final equation here, that basically becomes S is equal to U plus V times T by 2. So, this is the fourth equation of motion. But if you quickly think about it, there is another way of arriving at this equation. What is that way? Now, let's take this graph. You can see that the velocity is increasing uniformly. right? So how do I find the average velocity in this case? Average velocity is nothing but total displacement by time taken. So symbolically, the average velocity can be s by t, right? S being your final position. Of course, we have assumed the initial position to be 0. Do not forget that. So basically, S represents change in position, displacement, divided by time taken should give us average velocity. But from the graph, since the velocity is increasing uniformly, the average velocity can also be u plus v by 2. And that's true because of the fact that the velocity is increasing uniformly. It's linear. Which means if I rewrite this, I get u plus v times t by 2. Same as this one. So that's the fourth equation of motion. Thank you.